Section 9.6, classifying a conic section. What are our three conic sections that we have to focus on here? Three conics are the parabola, the ellipse, and the circle. Good. Okay, so there is a way to just look at the equation and know which one it is without even putting it in the form, in its standard form. If it's a parabola, it will have, you will only see, if you only see either x squared or y squared. That's probably the easiest. If you see only an x squared or a y squared, either x squared or y squared, it's going to be the parabola, because the forms are either x squared equals 4p y squared or y squared equals 4p, x squared equals 4py or y squared equals 4px. Only one of them is squared. If it's a circle, then you'll see x squared and y squared, but you might not have noticed this yet. They will always have the same coefficient, so that when you divide, it goes away. And you don't end up with anything on the bottom. And that will give you a circle. And it's an ellipse if you see both x squared and y squared, but with different coefficients. And that's why you can end up with something on the bottom. When you get one on the right, with the ellipse you have to have one on the right hand side. So you could get some denominators under x squared and y squared. With a circle you can't, because it'll always divide out. So those are the things to look for. So we're going to do 3 examples. There'll be one of each, and that'll give us a chance to review too. So the directions are the objectives. You'll be doing this a lot on the test. Classify and give information and graph. And you'll just be given the equation in standard form. So first example is going to be, first example is x squared plus y squared minus 2x plus 4y plus 1 equals 0. So you're often going to see this. And all your homework you'll be practicing. So which one is it? Okay, if it's an ellipse, it has x squared and y squared. Are there different coefficients in front? No. Coefficient is a number. No, so it's a circle. It's going to be a circle, and I'll prove that to you in a second. So you're always welcome to look at the standard form of a circle as we do this. You can have your formula sheet out, and it'll be printed on the test. But what you do is, we're going to review completing the square, okay? You've already listed the steps previously in your notes. You group the x's together, you leave space, you group the y's together, you leave some space for completing the square, and you move any other constants to the other side. So you subtract 1 from each side. So that's the first step. Group the x's together, group the y's together, get the constant to the other side. Then you make your magic little box for the number that will complete the square, and whatever you put, well, it actually depends. You have to balance the equation, so you put 2 squares on the, it's not necessarily going to be the same thing, you'll see in a second. So what would I add here to complete the square? 1. Yeah, half of -2 is -1 squared is 1. So plus 1, so I would add 1 then to balance the equation, and what's here? Plus 4, half of 4 is 2, squared is 4, and I would add it there to balance that. So now this is a perfect square trinomial because of that number. I made it that way. So you could go back to doing a diamond problem, or you would just know that it's always going to be a perfect square, and this number will always be half of this. It's the same sign as well. Half of -2 is -1. So we'll do the same thing here. What number goes here? 2. Half of that. If you don't believe me, do a diamond problem. What multiplies to 1 and adds to -2? -1 and -1. We have to add these numbers together. -1 plus 1 plus 4 is? Okay, good. See? Now it's in the form of a circle. And it's too easy to graph a circle. I don't need to tell you how to do that, but let's write the pertinent information. The center will always be HK. So an H always goes with X, and K always goes with Y. It's always been that way, even with trig, with every function family. So the center is HK, which would be 1, -2. It is the opposite sign of what you see, because it's x minus h squared plus y minus k squared equals r squared. Therefore, the radius is square root of 4, which is 2. Yeah. So be careful. Match it up with the form. It's r squared. R squared equals 4. Right? R squared equals 4. Therefore, r is the square root of 4, which is 2. And that's, you know how to graph that. Okay, let's move on to the next example. And you tell me which conic it is, and then we'll put it in standard form and graph it. So we have 2x squared plus y squared minus 4x minus 4 equals 0. Okay, so which conic section is it? It has to be an ellipse, because there's x squared and y squared, and the coefficient is different. It's a 2 here and it's a 1 here. Yeah, so it's an ellipse. And now we're going to do the same thing to review again. We're going to complete the square twice. So we group the x's together, 2x squared minus 4x. We group the y's together. There's only one y. That's actually a better thing. We don't even have to complete the square. And you move the constant to the other side. Now, there's one thing I've avoided talking about, but it's okay because I'm talking about it now, is if there's a leading coefficient here, you have to factor that out. You can't complete the square with some number in front. So we're just going to factor that out. And now I'm just going to recopy everything else as is. Okay, so don't forget to factor out any leading coefficient before you try to complete the square. You're going to have to do that before completing the square. Factor out the leading coefficient before completing the square. So these are equivalent, right? I just took the 2 out because I don't want anything. The standard form doesn't have anything in front of x squared, so neither can I. Okay, so now now you have to be careful because of that when you complete the square. We only have to do it once. Here we don't have to do anything because it's just alone. So what number do we add here? Yeah, just like before, half of -2, -1 squared is +1. But to balance the equation, you don't just add 1 here. What did I really add? Yes, because of the distributive property, right? What I really added to the left side was 2. Because 2 times, if I distributed this out, I really added 2. So you have to add 2 here. It's not the same number. It's what you need to balance the equation. Alright, so now everything else works the same. This factors x minus 1 quantity squared. And we're almost there. We know it's in a... Are there any questions so far? Yeah. Oh, that's a 6. Thank you. Good. Thank you. 4 plus 2 is 6. Any other questions? Okay, why does it not look like the ellipse yet? Well, we actually want, what do we want on the right side? We want a 1 here. So you will always, for an ellipse, you will always divide everything by whatever number's over here. So it's 6. You need a 1 here. Need a 1. So you divide everything by 6. So now we're almost there. It's going to look like it now. 2 goes into 6 3 times. So 2 6 is the same as 1/3. So that goes away. Equals 1. There we go. Now it looks just like an ellipse. So the center, to graph this, the center is at HK. H goes along with X, so H is 1. What's K? Zero. Yeah, there's nothing there. So the center is at 1, 0. Let me show you the fast way to graph this. It opens along the y-axis because the bigger number is under y. So I know that it looks like this. So I'm gonna plot the center 1, 0, 1, 0, and then I'm gonna go up and down along the y-axis the square root of 6. So the square root of 6, so you move along y the square root of 6. The square root of 6 is approximately 2.5. So I'm going to go up 2.5. I'm making 3 tick marks, and down 2.5. So I know it stretches the long way along y, along x. So this is along y. It's under the y squared, so it's along y. That's the longer direction. Along x is the square root of 3, which is approximately 1.7. So we'll go about 1.7 to the right and 1.7 to the left. And so there's our ellipse. And if you're asked for the major, the vertices, you would just, it would be easier to graph it and look. And the co-vertices are these 2 coordinates. I would just graph it first and then write the coordinates. Okay. If you're asked for the foci, you need C. So let's just review. C squared equals A squared minus B squared. So A squared is the bigger number, 6. B squared is the smaller number, 3. So C squared equals 3, or C is plus or minus the square root of 3. So you would move along the major axis, up root 3 and down root 3, and those would be your foci. Up root 3 and down root 3, and those would be your foci. On the test, I'll try to make them integers, so it's easier to do. But okay, so then the last one is gonna, well, you already know what it's gonna be, probably process of elimination. What have we not done? Yeah, parabola. So y squared minus 4y minus 2x plus 6 equals 0. So you know this is a parabola not just because it's the only thing we haven't done yet, it's because only y is squared. Only one of them is squared. Okay, so whatever one is squared, we're going to group those together on the left side. So y squared minus 4y stays together. But we have to move everything else to the right, because if you look at the standard form, and I'll write it right here, the standard form for this is y minus k squared equals 4p x minus h. You should be able to tell, look on your formula sheet, and you might want to write it down because that's what we're trying to get this into this form. So notice the x's are on the other side. So we're going to move everything else to the right side, 2x minus 6. Of course the signs change when you move it to the other side. So let's complete the square. We need a perfect square here. So what do we add? We add 4. So we add the same thing over here. So you get y minus 2 squared equals 2x minus 2. Negative 6 plus 4 is negative 2. So we're almost there. We need to factor out whatever's in front of x. We need to take it out. So 2 times x minus 1. And that's it. It's in the right form. So let's write down the pertinent information. The vertex is at HK. Be careful here, okay? H always goes with x. K always goes with y. So HK is 1, 2. Good. And we know it opens to the right because 4p is positive, okay, and it's y squared. If it's y squared, it opens right or left, and I think it says that on your formula sheet. So so it opens right. So to graph it, we would do, okay, 1, 2 is right here. So we've got the vertex. We know it opens right. We just don't know how wide it opens. So we need to find p. So you take 2 and you set it equal to 4p. 4p equals 2. Just matching it up. Solve for p by dividing both sides by 4. So p is a half. So you would move a half to the right, and that would be your focus, and a half to the left would be where your directrix goes. And then you would open to the right. Because they're closer together, this opens out more narrow. So it's so then you can just sketch it. You don't have to do any more specific points. I'm really concerned about you making it open in the right direction and being able to find the focus and directrix than whether it's the right width or not. Just approximate is fine. Okay, then the larger p is, the wider it is, and the smaller p is, the narrower it is. So p is a half, so it's kind of narrow. Okay.